All right, welcome back, you guys. Your favorite technical math class. We're going to take a look at volume. So this is also referred to as capacity, right? Our units are in cubic units. Like if we're in feet, then it's cubic feet. Um, it's like filling up a swimming pool, right? Like how much water do I have in the whole thing? Whoops. How much water's in there? That's our in cubic feet, right? We can also find a surface area, and so surface area would just be how much paint, if you're like, let's say we were painting the outside of this, right, around just the outside. That's our lateral surface area, just around it, right, around it. If I enclosed this, I had a top on it, that would be total surface area if I included the top and the bottom. That makes sense. Whoops, I don't know why it keeps erasing that. So we also are going to deal with some surface areas. Here's some equations for if we have box-like rectangular solids. And this is just showing us over here, it's a cubic units. How many cubic units you have, right, for volume. Okay, so volume is length times width times height for a rectangular solid. If they're all the same length, it'd just be the same length cubed, right? Side, side, side. And then our total surface area includes the top and the bottom as well as the side. So that's how much paint if I was to paint the whole thing. Okay. Lateral surface is just the front and the back as well as the left and right. That's a lateral surface area. Again, total surface area includes top and bottom. Okay. So let's go ahead and find the volume, total surface area, and lateral surface area for this rectangular solid. So number one, I just go ahead and write down volume is length times width times height. Let's find our volume first. Here's our length, here's our width, here's our height. And so we've got 20 centimeters times 8 centimeters times 16 centimeters, and we get 20 times 8, 160, 160 times 16, 2560 cubic centimeters. Centimeters times centimeters times centimeters. Okay. Now let's do our lateral surface area next. Lateral surface area. That's the area of the front and the back plus the area of the right and left. Okay, so the area of the front and the back, that would be length times height. So it's there in black right there. So there's two of those length times heights. So two of those length times heights plus, and let's go ahead and do that part. So that would be 22, because I got the front one and the back one. 20 times 16 plus, and now I'm going to do the right and the left. Let me do that in orange. Here's the right side, here's the left side. So there's 2 width times height. So I got 2, 8, and 16. So this gives me 640, and by the way, this is centimeters, that's centimeters, so that's square centimeters. And then over here I got 16 times 16, 256. So 256, again, that's centimeters and centimeters, so square centimeters. This is like how much paint you have. And then 640 plus 256 gives me 896 square centimeters. So our surface area, just like area, lateral surface area is in units squared. Units squared. All right, now we're going to move into total surface area. So number 3, total surface area, which is the lateral surface area, so the area of the front and the back and the area of the right and the left, but it also includes the top and the bottom. So area of the top and the bottom. Well, we already have these two, right? That's our 610 and 256. Or I'm sorry, 640 and 256. So those two together was our lateral surface area. We already have that. So we just got to throw in the top and the bottom, which is 2 times the length times the width. So we've got 896 plus 2 times the length, 20 times the width, 8. And so we've got 2 times 20 times 8, we got 320 plus 896 gives us 1216 square centimeters. That's our total surface area. Now we're going to look at a right circular cylinder. And so with the volume of that is the volume of this base here, which is a circle, right? Well, the area of a circle is pi r squared. You see the pi r squared right there? And then if you multiply in this height times the height, you'll get the volume. So pi r squared h, that's the volume of a right circular cylinder. It's the area of the base times the height, right? The area of that circle is pi r squared. Now, what about the surface area? So the total surface area, I should say. Let's do the total surface area. Well, if you think about, let me cut off the top and the bottom. So I cut out that, I cut out that. There's my top, there's my bottom, right? So it's the area of those two. So the area of the two squares, so pi r squared times 2. That's the area of the top and the bottom. And then if you think about, let me cut this right there and unravel it out. And I would get this rectangle right here. If I cut it with some scissors and unraveled it, right? And the length of that would be the circumference of the circle because it's unraveled. Well, the circumference of a circle is 2 pi r. So that's this length right here. And then the height of it's that h, so times the height. So that's where the area of the side comes into play, 2 pi r h. And so that 2 pi r h is actually the lateral surface area, right? Because the lateral surface area will not include the circular top or bottom. Okay, so that's where the lateral surface area is. The total surface area incorporates the two circles on the top and the bottom. Okay, so let's go ahead and do this example 2 here. Determine the volume, lateral surface area, and total surface area of a right circular cylinder. Let's go ahead and draw this right circular cylinder where we have a radius of 2. Radius is 2 meters, and this height of 4 meters. So number 1, our volume would be pi r squared h. So we got pi 2 meters is being squared times a height of 4 meters. And so we've got 2 squared is 4 times that other 4, 16 square meters. Okay, so our volume is 16 pi square meters. And then make sure you go ahead and punch that in. They want it both in exact form, that means with the pi, and I also want this in decimal form, and in this case rounded to the 10th position. So I go ahead and pull up my decimals, punch in 16, and you can punch in pi for pi, or you can get that right there, and I get 50.26548.246. I'm going to go ahead and punch that in here, and we'll round it. So there it is in exact form, which is 50.26548.246. We're going to round that to the 10th position. So I look to the right of the 2 there, I look at the 6. If it's 5 or more, bump it up, right? There it is in decimal form. All right, now we're going to do our lateral surface area. That's like if I cut this and unravel it. I cut it, I unravel it. My length of that rectangle would be the circumference. Well, that's 2 pi r. And the height of that would be the h, 4, right? And that's, again, if I unravel it just around it. Whoops. I unravel that around, and I'm just getting the lateral. So not including the top and the bottom, right? It's just how much paint around it. So lateral surface area is 2 pi RH. So I got 2 pi. My radius here is 2 meters. My height here is 4 meters. And so this actually ends up being 16 pi as well, interestingly enough. Doesn't always happen that way. So there it is. Oops. Oh, come on. There's my lateral surface area in exact form, which we already rounded that to 50.3. So happens to be the same on that one. Not always that way. Now, our total surface area would be that lateral surface area plus the two circles on the top and bottom, right? Area, the area. Let me do it this way. Plus the area of the top and bottom. Area of the top, bottom, which is the two circles. So that'd be the top, that'd be the bottom, right? In green there. So our lateral surface, which is 2 pi RH or 16 pi, plus two of these circles. Well, the area of a circle is pi r squared. So we got 16 pi plus 2 pi. My radius here is 2. So I got 16 pi plus 2 squared is 4. 4 times 2 is 8. 8 pi. So I got my total surface area is 16 plus 8, 24 pi. Or, and then I go ahead and punch that in. Let's punch in 24 times, go ahead and find your pi button. Oops, 24 times pi, and I get 75.39822366862. I round that to 75.4. So there it is, exact form and in decimal form. All right, let's take a look at a sphere now. Volume of a sphere, so it'd be like volume of a basketball or soccer ball, volleyball, right, something like that. A sphere would be that 4/3 pi r cubed, and then we've only got a total surface area here, which would be 4 pi r squared if I was to see how much paint it would take to paint around it, right? Total surface area. And so let's go ahead and find that. Find the volume with if you've got a radius of 12 inches. So our radius here is 12 inches. Number one, our volume is 4/3 pi r cubed. So I got 4/3 pi. My radius is 12 inches cubed. So I punch that in. 12 times 12 times 12 gives me 1728, and this is cubic inches. Let me take this up here. This is over 1. So now I got 1728 times 4 is 6912. I got that pi still. Over 3 times 1 is 3. So I got 2304 is my volume pi. And it's in cubic inches. Okay. Or approximately, if I multiply by pi, I get, so there it is in exact form, 7238.2294738.709. I want to round it to the 10th position again right there. So 7238.2. is that 2 to the right of it leaves it the same. So now our number 2, our total surface area would be 4 pi r squared. So I got 4 pi, my radius here is 12 inches, it's being squared. So I got 4 times pi, 12 times 12 is 144 square inches. So then I got 144 times 4, which gives me 576 pi square inches is my total surface area. Now let me go ahead and multiply that by pi, and I get 1809.557.368.4677. So if I round that, oops, 0.6, right? If I round it to the 10th position, square inches. So we're going to do a cone now. So we've got a three-dimensional shape. We've got a circular base, and it narrows smoothly to a point referenced as the apex of the cone at the top there, the apex, right? We're just going to do our volume on this. So 1/3 pi r squared h. So if you've got a cone here, here's our apex up the top, and the radius here is 5 feet. And then it's right circular, meaning it makes a right angle for this height here, our altitude. Our height would be 4 feet, it's telling us. Let's go ahead and find the volume, 1/3 pi r squared h. So we've got 1/3 pi, our radius here is 5 feet squared, and our height here is 4 feet. So we got 1/3 pi, 5 times 5, I got 25 square feet times 4 feet. So now I got 1/3 pi, I got 25 times 4 is 100. Feet squared times another feet is cubic feet. And this is over 1. So 100 times 1 on the top is 100. 3 times 1 is 3. I still got the pi. This is square feet, right? There it is in exact form, 100 thirds pi, because 100 thirds is does not go evenly, right? So there it is. Now I'm going to go ahead and take 100 divided by 3, and I get 33.33333 on my calculator, and then just put in times pi, and you'll get the decimal form of this. So 104.71975511196. We're going to round to the hundredths position. That's the second one. So look at the 1 there. I go to the right of the 1, which is a 9, and that'll bump it up. 104.72 cubic feet. Now, if we have a rectangular base that narrows smoothly up to the height, up to that apex there at the top, then we'd have a pyramid, right? So we'll work with some right rectangular pyramids, being that the height there goes right down to the middle. So, and we're just going to do the volume on these as well. So it's the area of the base, which we know the area of the base is length times width, right? Because it's a rectangular base. And then times its height. So length times width times the height, 1/3 of that. That's our volume for a pyramid, okay? So let's go with the Luxor Hotel right here in Las Vegas. It's said to be based on the same shape as the Great Pyramid of Giza, if you didn't know that. And let's go ahead and find the volume of the Luxor. So the volume, so I got 1/3 length times width times height. And so let me see if I can't draw, oops, this as best I can. Here's my height. It has a height of 350 feet, the Luxor. And it's got a square base, actually. It's not rectangular. So the length is 600 feet, but so is the width. They're the same. It's got a square base, similar to apparently to the Great Pyramid of Giza as well. So let's see how it compares to the Great Pyramid of Giza in terms of capacity. So we got 600 feet times the width of 600 feet, and of course a third of this, right, times 350 feet. So I take my calculator and I punch in 600 times 600 is 360,000 times 350 is 126 million. So I have a third of 126 million. So I divide that all by 3 and I get 42 million. Feet times feet times feet, cubic feet. Okay, so here's our Great Pyramid of Giza. Oh, I'm sorry, there's the Luxor. There's the Luxor's capacity or volume. How does it compare to the actual Great Pyramid of Giza, which is 91,227,778? So it's not even quite half the size, the volume, the capacity. Isn't that interesting? Anyways, that's how you find the volume of a pyramid. Thanks so much for taking notes. See you next time.